Okay, our start of Chapter 9, Section 1 is going to be absolutely the shortest video ever because our notes just one page as we introduce the concept of conic sections. Now, I'm also going to include links to a couple of places where you can find animations for conic sections so that you can see what exactly we're doing when we take conic sections. The word conic derives from the word cone, and a cone is constructed by two distinct lines that intersect at a point. So you're thinking about taking two lines, two verticals that intersect at a point and rotating them around each other. When they rotate around, they form the cones. Now, what we talk about as a cone is actually more appropriately referred to as a nap. What you see here are two naps that intersect at a vertex. So this is a nap. What you would think of as a cone is a nap, N-A-P-P-E. They connect at this vertex right here, and they're generated by two lines that are offset, like I said, and this is hard to see from the vertical document camera, but they're offset and they rotate around each other to swing out and form the naps. Now, if I sliced those rotating units at a certain angle, you would get different shaped conic sections. The conics are curves that result from the intersection of a right circular cone, circular cone, and a plane. So let's look at a couple of definitions. Right circular cone. It is right because the apex or the vertex is directly above or below the center of the circular base. If it were oblique, that would be offset. So if you thought about a cone that was oblique, it would look more like this. It would still be cone shaped, but the apex, the vertex, would be offset from center. That would be oblique. But we have a right circular cone, and we have a plane. A plane is just like taking a sheet of paper or a blade and sliding it through the cone at a different, or the nap at a different angle. The conic section, the shape of it is determined by the angle at which that blade or that plane slices through the nap. Circles are formed when this plane is perpendicular to the axis of the cone when it intersects. So here is my axis. My axis goes straight down through the vertex so that it goes through the center of each of these circular bases. When this plane that cuts through a nap is perpendicular to this axis, this portion that is cut is going to be a circle. Now, where that moves depends on the size, the radius of the circle. Here, the radius of the circle is larger than it will be closer to the vertex. If I move out further from the vertex, the radius of the circle gets larger still. An ellipse, or an oval is what we typically call an ellipse, is what occurs when the plane is tilted slightly when it intersects the cone or the nap. So you can see it's no longer perpendicular to the axis, but it goes through at an angle so that it's still within one nap, and the section that is revealed would be this ellipse shape. Now, parabola. We know what a parabola is, right? So, okay, let's label some of these. This is going to be A, and this is B. There's my ellipse. This is going to be C. We get this parabola shape, the singular parabola. So when the plane is tilted, not tiled, another typo on their part, tilted farther so that it is parallel to one generator. Now, what's a generator? The generator is that line that is rotated to form the cone, to form the nap. Now, when we take that generator and you see that it is at this angle, if I put a plane through that is parallel to that, so that this line and this line are parallel, the resulting conic section will be a parabola. Now, in the I want to challenge you to go through the animations that I post and see if you can make it stop on parabola, because it's only parallel. This generator and this plane are only parallel for an instant, right? And then it's going to move past that place where the two are parallel, and you have a different, they're going to be intersecting at some point. Okay, then we have our hyperbola. The hyperbolas occur when the plane intersects both parts, both naps. So we have tilted it enough that not only do we not have an ellipse, we have gone past this parabola so that this plane now is cutting through a piece in each of the naps. And so I have kind of two parabolas that are opposite each other, and that's what we call a hyperbola. That's our conic sections, guys.